Hi, in this video, we are going to be looking at section 4.7, which is solving counting problems. So the main thing with this section is we are going to be dealing with questions that are permutations and questions that are combinations. So key thing is knowing when you're dealing with each. Now, in some cases, you'll also have some questions that can be solved by either. So for this section, it's important to know when to use permutations and when to use combinations. So permutations are when order matters. So for example, you have a race, you want to know who finished first, second, third, fourth. Combination is when order does not matter. So for example, you're hiring 6 people out of a group of 20. The order they're hired doesn't matter. Okay, so for example, in a 649 lottery, these 6 numbers are selected from 49. How many different tickets are possible? So first thing is, we're looking at this, we want to know, does order matter? Now, there's nothing in here that indicates order mattering. And in fact, with a 649 lottery, 6 numbers are selected, they're then just reordered in ascending order so people can easily check their tickets. So this one, order does not matter. So therefore it would be a combination. So we have NCR. And we're selecting 6 numbers, so that's our R, while our N is 49. So we have 49 C of 6. So that gives us 13,983,816. Example, you're creating a 15-song playlist out of 35 songs. How many ways can you listen to the songs? So this one we have to consider, does order matter? So if you're listening to a playlist, the playlist is going to be different to you depending on what order those songs are in. So if this one, permutation would matter, or sorry, it would be ordered matter, so therefore it's permutations. So we have NPR, so we have 35 as our N value, and R is 15. So we have 35 songs, we're choosing 15, and we want to know how many different unique playlists can be created. So we've got 35P of 15, use the app on our calculator, and we get 4.25 times 10 to the 21 different possibilities. Next example, how many different 5-card poker hands can there be with exactly 2 black cards? So in poker, you're not looking at what order people are getting cards in. Instead, you're trying to find, say, pairs or 3 of a kind or 4 of a kind or flushes and things like that. So the order people are getting cards does not matter. So it's going to be a combination. However, this one has a little extra to it because we can figure out how many different hands they can have that have 2 black cards. So in a deck of cards, we've got 52 cards, half for black, half for red. So we're selecting 2 out of 26 cards that are black. Now, if there's exactly 2 black cards, that means there is going to be 3 red cards. So we're going to multiply this by the different possibilities of 3 red cards that can be chosen. So we've got 26C of 3. So the amount of 5 card poker hands with exactly 2 black cards. So this would be how many ways we can choose those 2 black cards times how many different ways we can have for 3 red cards. And that tells us we have 845,000 different possible hands that match this criteria.